Hello guys, welcome all of you. Today we have to see next part of oscillators, definition of oscillator, Barkhausen criteria and concept of AF and RF oscillators. Before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, what is the definition of oscillator? It is a circuit which converts DC energy into AC energy at very high frequency. So see here, if we apply the DC power supply to this oscillator circuit, it converts into AC energy at very high frequency at the output. So see, oscillator means what? Oscillator operates on the principle of positive feedback. So what is positive feedback? We seen in the last lecture. Please watch these lectures first and then this lecture. So oscillator operates on the positive feedback. That is, what is mean by positive feedback? When input signal and feedback signal are in phase, the feedback is called as positive feedback. Hence, oscillator is an amplifier with positive feedback. It produces the output signal so long as the DC power supply is connected. Frequency of the output signal is determined by the passive components used in oscillator circuit. So what is mean by passive components? That is, passive components means resistors, capacitors, inductors, like that. So an amplifier acts as an oscillator if and only if it satisfied Barkhausen criteria. So see the Barkhausen criteria. The condition under which amplifier can work as an oscillator is known as Barkhausen criteria. So it is implies that magnitude of the loop gain, that is loop gain A into beta, which is equals to 1. And the second thing is the amplifier should have positive feedback. So these two conditions for the oscillator, that is, it is work as an oscillator. For the amplifier work as an oscillator, these two conditions satisfied. Then see concept of AF and RF oscillators. So oscillators are classified on the type of feedback. So first is RC oscillators, next is LC oscillators, another is crystal oscillator. So first see RC oscillator. These oscillators are used resistors and capacitors and are used to generate low frequencies. These oscillators are called audio frequency oscillators, which generates waves of 20 Hz to 20 kHz. So example of RC oscillator is phase shift and Wien bridge oscillators. Next one is LC oscillator. These oscillators uses inductors and capacitors and are used to generate high frequencies. These oscillators are called radio frequency, that is RF oscillators, which generates waves of frequencies in the range 20 kHz to 30 MHz. Examples of LC oscillators are Colpitt's and Hartley oscillator. Then another is crystal oscillator. It is used to generate highly stable output signal with very high frequency. So these are the oscillators type on the basis of feedback. That is, in the feedback network we use which network, that is RC network, LC network, or in the crystal oscillator we use crystal also. So these are the types of oscillators. So next part, in the next lecture we have to see the phase shift oscillator in the next lecture. Thank you.